This video is by Mark Kingston from the ARA Institute of Canterbury in Christchurch, New Zealand. Right, so this video here is on Pythagoras' theorem and how it relates to triangles. So I've drawn a right angled triangle here, this little symbol down in the corner indicating that it's a right angled triangle. Has two shorter lengths and has a longer length down the far side here. So Pythagoras' theorem states that c squared equals a squared plus b squared. The c in this case is always the longest length, which is actually the hypotenuse on a right angled triangle. The two shorter lengths, if you look at trigonometry, one is the opposite, one is the adjacent, depending on where the angle sits. But for Pythagoras, it's just one short length on one side and one short length on the other side. So to determine c from this equation, if we want to isolate c, if we're trying to find it, what we have to do is take the square from one side and transpose the formula by putting it on the other side. When we stick it to the other side, it becomes c equals the square root, because the square, when it goes to the other side, opposite side of, or the other side of the equal sign, becomes the square root. So what we end up with is a squared plus b squared. So if we start off with two shorter lengths, we can actually identify the longer length with that formula. If we start off with the long length and one short length, we can identify the other short length by changing, sorry, I've gone and made a mistake there, I'm going to rub that out and smear it everywhere because it's wet. What we would do is we would write it as, for instance, a equals the square root of c squared minus b squared. Now, you could also write it as b equals the square root of c squared minus a squared. It doesn't particularly matter, whether you call this side a and this side b, or whether you change them over. So for this one here, I'm going to say that a equals 3 millimeters. Written rather roughly, and b equals 4 millimeters. And I can already tell you that c is going to equal 5 millimeters, and the reason is that it's what's known as a Pythagorean triple, where you have a triangle, you have a 3, 4, 5 triangle. They are all whole numbers. There's no decimal places after them. So I'm going to do it on the calculator to show you. So using the formula of trying to find c, starting off with the a and the b. So we want c, we want the square root of a squared plus b squared. So turning the calculator on, what I'm going to do is I'm going to push the square root symbol for a start, and then I'm going to put in a as 3 squared plus b 4 squared, and I'm going to push the equal sign, and as you can see, it's come up as 5. So that's, that's a very common one. People that, doing boxing or trying to get something square, you can measure down one leg 3 units. Doesn't have to be millimeters, could be meters, could be kilometers. Up 4 units, and the line across them would end up being 5 units if you had a square. So we can have some different Pythagorean triples. There's many. I'm going to do another one here. This time I'm going to start with 5, 12 and 13. So I'm going to draw another triangle here and I'll explain it a wee bit more. So this is 5 units. We'll say that this is 13 units, and we want to identify this length across here. So this time we're going to start with this formula here. We're going to say that we've got the hypotenuse length, which is the c squared, minus the b squared. We'll call this b, and this one's going to be a. So this time when we put it into the calculator, I'm going to do it slightly different. Previously I pushed the square root symbol, and then I pushed a squared plus b squared. What I want to do this time is I'm just going to, instead of pushing the square root symbol at the start, I'm going to put 13 squared minus the 5 squared, and I'm going to push equals. Now it's 144. Now you want to take the square root of 144. So 144 is actually in the memory of answer, ANS down the bottom of the calculator. So if I push the square root symbol, the 144 disappears off the screen, and you need to push the answer where the 144 is retained in the memory. So it becomes square root of the memory, or square root of answer, and push that and you get your 12. And that's our 12 there. So why do we end up with a 5, 12, 13 triangle? Well, we're squaring it. So 5 times 5 equals 25. 12 times 12 equals 144. 25 plus 144 is 169. If you take the square root of 169, it equals 13. And that's what we have up here. So I'll do that on the calculator. So just to reinforce it, square root of 169 equals 13, just to prove it. So now let's say you've got a triangle, or you've got odd lengths that actually have decimal places in them. So we'll do another one here. Right angle symbol. We'll start off with two short sides. We'll say that this side here is 17.8 millimeters, and we'll say that this side here is it's a bit shorter, so we'll say it's 13.9 millimeters, and we want to determine the long length. So we've got the two short lengths. We take the square root of those after we've squared them, and that'll give us C, which is this long length on the triangle. So back to the calculator, I'm going to type in the square root symbol for a start, and then I'm going to push. It doesn't matter whether this is A and this is B, or vice versa. This could have been A and this could have been B. It makes no difference in the formula. It'll still give you the answer you're looking for up there. So I've typed in the square root symbol. I'm going to push 13.9 squared plus 17.8 squared, push the equal sign, and we get 22.58 to 2 decimal places. So that's what it would be in terms of millimeters. 17.8 squared plus 13.8 squared, take the square root of that, and you get a long length there of 22.58. So you can actually use different Pythagorean triples if you can look them up on the internet. There's hundreds of them on Wikipedia if you want to use them. Or you could just have a basic understanding of trying to lay something out with a 3, 4, 5 triangle. You don't even have to do a calculation. You just measure 3 units one way, 4 the other way, run a tape across here, and pull one leg in until the 5 hits the outside point of the 3 and the outside point of the 4. That gives you an absolute square. Not much more to say really. The different combinations of the formula, practice them, you'll actually come to terms with it pretty quickly. Look at the calculator to see the different way that I punch the numbers into the calculator. I either use the square root symbol at the start, or I square rooted the answer at the end to give me the figure that I was looking for. So you can do it either way if you're confused as to how your calculator works. So we'll leave it there, thank you.